Yes? Okay, cool. All right, let's move on. Order of magnitude. I'm going to give you a definition right now, and then we're not really going to talk about it until the end of the notes. But I'm just going to do that right now. Okay, more is a power of 10 nearest to the quantity given. Now, I'm going to show you examples of what I mean. A power of 10 nearest to the quantity given. Okay, power of 10. Let's talk about what power of 10 is. 10 to the 1. What value is that? What value is that? It's just 10, isn't it? What's 10 squared? 100. I'm going to put 100 underneath here. What is 10 cubed? I'll tell you how I know. Yeah, don't do it on the calculator. The exponent tells you how many zeros. When you have base 10, the exponent tells you the zeros. So 1, 2, 3. It's 1,000. What would 10 to the 6 be? I don't know. Let's write 1 and 6 zeros. What's that? 1,000,000. These are powers of 10, okay? That's a power of 10. So back to order of magnitude. If they give you, like, say, for example, you have 91 pens, and I have to write that as an order of magnitude. I'm going to abbreviate order of magnitude. What is the 91 closest to of these numbers? 10 to the 1, 10 squared, 10 cubed, 10 fourth. 91 is closest to which one? Come on, don't be shy. 10, 100, 1,000. What's its closest to? 91. 100, right? It's closest to 100. So the order of magnitude would be 100, but we have to write it as a power. So 10 squared. Order of magnitude would be 100. That's the closest number of powers of 10. Now let's do another one. Let's say I read this in the book. I did not know this. There's 91,000 insect species in the U.S. If I had to write that as the number closest to the power of 10, I would just underneath write this. And I'd say, okay, is 91,000 closest to 10,000 or the next one up? What's it closer to, 10,000 or 100,000? Right, so I got to make it this, 100,000. I got to round it up to 100,000 and write that as a power of 10. So I'm going to put 100,000 here. And I'm going to write it as 10 to the what? How many zeros? 1, 2, 3, 4, 5. 10 to the 5. Order of magnitude. You use this in science a lot. Have you ever heard of it before? When you have to talk about really big numbers? I know you've heard it before because I taught it in 8th grade. Okay? All right. So we're going to look at that later. This whole chapter, this whole section is about 3 properties. But before I even go there, it says products of powers property. I want to define what a power is. So I want you to write this right here, and I want you to circle it. Circle. 3 to the 4th. Okay, those two numbers together are called a power. Together. They're called a power. This number right here is a what? Don't take a sucker out of my drawer, dude. Okay. Okay, the bottom number is called the base. What's that called? The exponent. You need to know these words, or it's not going to make sense what we're doing, okay? The whole thing together is called a power, an exponent, and a base. Now, products of powers property. Product means to multiply when you're multiplying. Multiplying powers. To multiply powers having the same base, you keep the same base and add the exponents. Keep the same base, add the exponents. Can you put that away? Thank you. All right, so let's look at what we have here. I have a power times a power. They have the same base. This is telling me, wow, something weird happened here. This is telling me that I have 7 4s. You don't have to write this all out, just look. 7 4s times 6 more 4s. Wow, that would be a pain in the butt to write that all out, wouldn't it? How many 4s do I have altogether being multiplied? 13. Oh, that's what that says. To multiply powers having the same base, you keep the same base and you add the exponents. So all I really have to do is 4 to the 7 plus 6 equals 4 to the 13. I'm done. Add the exponents when the base is the same. Okay, I know this is kind of in the way here. Now, let's look at this. I have 8 to the 5th times 8 to the what? First. Oh, yeah. There's only one 8 sitting there. But there is an exponent, we just don't write it. Times 8 squared. So how many 8s are being multiplied together altogether? 8 to the 5 plus 1 plus 2, which would be 8 to the 8. Okay? All right, this one here. Negative 3 is my base. That stays the same. I have 3 of them here, and how many here? 1. Negative 3 to the 4th. So let me ask you something. Anybody know? Would this give me a positive answer or a negative answer if I was going to multiply those out? Liam? Why? Oh, okay, but what if this was a 3? Oh, wait a minute. Let's.
Because it's you have to multiply it. It's a negative times a negative times a negative.
So I have 4 negatives is going to give me a positive, right? 3 negatives is going to give me a negative. Anytime, and you don't have to know this right now, but anytime you have an even exponent with a negative base, you're going to get a positive answer. If you have an odd exponent with a negative base, you're going to get a negative answer. Just for future reference. This is your answer here. Okay, last one. B to the what?
11.
It is. It's 1 plus 3 plus 5 plus 2 is b to the 11. Okay. This is the first property that you're going to be working with. Now let's look at a couple more on the back here. Power over power property. So you keep the same base and you multiply the exponents. So what this means is I have a power here, correct? X cubed is a power, yes? I'm going to take that power and have it raised to another power. Power of a power. And so what I do is I multiply the exponents. But let's look. See how this is different than those? See the difference? So this is saying, let me start with this one. This is saying I have y cubed times itself 3 times. So y cubed times y cubed times y cubed. Oh! How many y's do I have altogether? 9. Now that's a pain to write that all out. So really all I have to do is 3 times 3. What's 3 times 3? Y to the 9th. It equals y to the 3 times 3. It's obnoxious, isn't it? Can you shut that door for me, Tony, please? Okay. So, therefore, I have 7 to the 4th 5 times. How many 7s am I going to have? 4 times 5. I'm going to have 7 to the 20th. Here I have negative 3 to the 4th. Don't worry about the brackets. It's just because we have parentheses there, instead of putting another parentheses, they put brackets. It doesn't really mean anything. It's saying negative 3 to the 4th twice, or squared. So I just do negative 3 to the 4 times 2, which would be negative 3 to the 8th. Power over power. All right, here you have to consider this whole thing. The whole thing is the base. The whole thing. You don't change that at all. That's your base. So I have now n plus 8 to the 2 times 9. I have n plus 8 squared 9 times, so I'd have n plus 8 to the 18th. That's my answer. You don't do anything else with it. Okay, that's the second property that you're going to be working with. Third property. Power of a product. This means multiply, that means power. To find a power of the product, you distribute the exponent to each base number or variable. You distribute the exponent to each base number or variable. Okay, this is where third hour got a little confused. Well, not yet. So here, I have 34 times 9. So I'm going to take that 6 and put it on both of them. Don't be distracted. Okay? 34 to the 6 times 9 to the 6. It's exactly the same value. You say, yeah, how does that make a difference? It doesn't really with this problem, but ultimately it will when you get into more complicated algebra. And that's your answer right there. Now here, you take that 3 and you put it on all of them, even the number. So you have 4 cubed times m cubed times n cubed. I don't care if you leave your answer as 4 cubed. You can go to the calculator and find out that that's 64 and write 64. That doesn't matter to me. So you could write it either way. Both ways would be correct. Doesn't matter. Okay? All right, 4 on the negative 2 and 4 on the g. Negative 2 to the 4th, g to the 4th. I put that 4 on both of the things inside there. Now I can do this in my head. Let me ask you though, even exponent, is this value right here going to be positive or negative? We just talked about that. It's positive. Negative times negative times negative times negative would give me a positive 16 g to the 4th. And you could write it either way. I don't care. Both ways are fine. That's not a fraction, by the way. It's just 2 boxes. Okay, now this one is a little bit different. Notice the negative is outside. It's very important to notice that that negative is outside of the parentheses. That negative is not being squared. Only the stuff inside the parentheses. And it's actually the same as negative 1 5x squared. Okay, negative 1 5x squared. So now I'm going to finish this problem. I'm going to leave the negative 1. I'm going to put that squared on both of the things inside the parentheses. 5 squared x squared. Okay, so now I can easily do 5 squared. What's 5 squared? Yeah, if you can easily do it, then do it. And then I can multiply those two, and ultimately my final answer is this. Now I'm going to add one problem in here that kind of came up when they were doing the worksheet, so I'm just going to put like a little square here. And put this problem down, 10x squared to the 3rd. Put that one in there. It's the same as the rest of them. What did we do on the rest of them? We put the 3 on both of these, but oh, wait a minute. It's bringing in 2 properties. It's distributing that 3, and what do I have to do here? I got to multiply those, right? Just like we did up here. So it's going to end up being 10 cubed x to the what? 6, 2 times 3. So it's incorporating 2 of the properties. Sometimes you'll use all 3 of the properties in one problem. So you're kind of going to practice that, okay? All right, order of magnitude. Let's use order of magnitude here and then we'll be done. A box of staples contains 10 to the 4 staples. How many staples do 10 squared boxes contain? And you may say, oh, that's really confusing. But it's not. Think of it this way. If you have a box, I'm ignoring these numbers. If you have a box of, let's say, 100 staples. This is just a let's say. And you have 2 boxes. How do you find out how many total staples? 2 times 100, right? Well, this is asking you the same question. A box of staples has this many staples. How many staples do this many boxes contain? So you just multiply. 10 to the 4th is each box times 10 squared, which is the number of boxes. And this is one of your properties. Which one is it? What do you do here? Do you need to know the property? No, but you need to know what to do. Same base, what do you do to the exponents? Add them, because you're multiplying with the same base here. So it would be 10 to the 4 plus 2. And your answer would be 10 to the 6. Which you could leave like this, because that is order of magnitude, but I want you to start thinking, as a number, what would that be? How many zeros would it have? How many? 6. It tells you right there. So you would put a 1, 1, 2, 3, 4, 5, 6. 1 million staples. That's a lot of staples. Okay? All right.